In this video, we're going to go over series and parallel circuits. So consider the following two circuits. Here we have a battery and a few resistors. Which one of these circuits represent a series circuit and which one is parallel? By the way, you can view the resistors as light bulbs. A light bulb acts as a resistor. The one on the left is a series circuit. The reason being is there's only one path for the current to flow. In a parallel circuit, which is what we have on the right, there's multiple paths for the current to flow. The current can flow in this direction or it can flow in that direction. The longer side of the battery is the positive side and the shorter side is the negative side. Conventional current flows from positive to negative. Conventional current represents the flow of positive charge, but electrons, they flow in the opposite direction, from negative to positive. In a series circuit, if you connect two light bulbs in series together, the light bulbs will appear to be dim relative to the parallel circuit. If you connect two light bulbs in parallel to each other, the light bulbs usually will appear very bright. That's because as you add resistors in a series circuit, the total resistance increases, which decreases the current. So let's say if you put 3 light bulbs in series, it's going to be even dimmer because there's less current flowing through it. Whereas in a parallel circuit, the voltage is the same. So it doesn't matter how many light bulbs you add. As long as you have a strong enough battery that can dish out enough current, each light bulb will remain bright. As you add resistors in a series circuit, the resistance goes up. But as you add resistors in a parallel circuit, the overall resistance goes down. But more current is drawn from the battery to power those extra light bulbs or resistors. Now let's solve a series circuit. So let's say if we have 2 resistors, and let's say the first one has a resistance of 4 ohms and the second one 6 ohms. Let's say we have a 30-volt battery. How can we calculate the current that flows in a circuit? By the way, in a series circuit, the current that flows through the resistors that are connected in series is the same current. In a parallel circuit, the voltage across resistors that are connected in parallel is the same. Now in this problem, the first thing you want to do is find the total resistance. In a series circuit, it's simply R1 plus R2. And if you have a third resistor, plus R3. So it's 6 plus 4. The total resistance is 10. Now the next thing you need to do is use Ohm's law. V is equal to IR. If you use the total voltage of 30 volts and the total resistance of 10 ohms, the current that flows through the circuit is 30 divided by 10, so it's 3 amps. So 3 amps of current leaves the battery and flows through each resistor. Now, what is the voltage drop across each resistor? So let's start with the 6 ohm resistor. What is the voltage across it? So we have 3 amps of current flowing through the 6 ohm resistor. To find the voltage across it, use Ohm's law, V equals IR. So 3 amps times 6 ohms gives us a potential difference of 18 volts. Now what about the 4 ohm resistor? Using the same equation, we have a current of 3 amps flowing through a 4 ohm resistor, so the voltage drop is 12. So we have 18 volts across the 6 ohm resistor and 12 volts across the 4 ohm resistor. Now let's make some space. Let's just get rid of some of the stuff that we have here. notice that the voltage drop across each resistor adds up to the voltage of the battery. And it makes sense. According to Kirchhoff's voltage law, the voltages around any closed circle or any closed loop always add up to 0. So let's say if this point has a potential of 0 volts, that means the voltage potential at this point is 30. The positive side of the battery is 30 volts higher than the negative side, and this would be 12. So if you go around the circuit, the voltages should add up to 0. So let's travel clockwise. So if we go this way, the voltage increased from 0 to 30. So that's positive 30. And it makes sense because the battery, it supplies energy to the circuit. Voltage is defined as electric potential energy per unit charge. 1 volt is 1 joule per coulomb. So the battery, it increases the voltage of the circuit. Now, as we go through the resistor from 30 to 12, we experience a voltage drop. And it makes sense because the resistors, they consume energy in the circuit. So we have a voltage drop of 18 volts, which is the voltage across the resistor. Now going from 12 back to 0, we have a voltage drop of 12. And so these numbers add up to 0, which is the sum of the voltages around any closed loop. And that's related to Kirchhoff's voltage law. The next quantity that we need to calculate is the power. The power delivered by the battery and the power absorbed by the resistors. So power is equal to voltage times current. Now there's two other forms of this equation that you might find useful. Now we know that V is equal to IR. So if we replace V with IR, then we'll get the second form of the equation, which is I squared R. Now, since V equals IR, if we solve for I, V divided by R is I, from Ohm's law. So we can replace I with V over R. So another form of the equation is V squared divided by R. So we're going to use the different forms of that equation to calculate the power. So let's find the power delivered by the battery. The battery has a voltage of 30 volts and it delivers a current of 3 amps. So 30 times 3 is 90. So the battery delivers 90 watts of power. Now what about the 6 ohm resistor? How much power does it absorb? Let's use the second form of the equation. P is equal to I squared R. So the current that flows through the 6 ohm resistor is 3 amps. So 3 squared times the resistance of 6. 3 squared is 9. That's 3 times 3. And 9 times 6 is 54. So the 6 ohm resistor absorbs 54 watts of power. Now, what about the 4 ohm resistor? How much power does it absorb? Let's use the third form of the equation, V squared divided by R. So the voltage across the 4 ohm resistor is 12, and it has a resistance of 4. So we can do 12 times 12 divided by 4, or we can do 12 divided by 4, which is 3, times the other 12, which is 36. 12 squared is 144, and 144 divided by 4 is 36. Either case, the 4 ohm resistor absorbs 36 watts of power. Notice that the total energy absorbed, or the total power absorbed by the two resistors, adds up to the power delivered by the battery, which is 90. 54 plus 36 adds up to 90. Now, what exactly is power? How can you define power? Electrical power, or power in general, is work divided by time. 1 watt is 1 joule per second. So power is a rate, is the rate of energy transferred. So for example, let's say if you have a system that could transfer 100 joules of energy in 1 second. And if you have another system that can transfer 100 joules of energy in 10 seconds, which one has more power? Well, it's going to be the system on the left. Now, granted, both systems can do the same amount of work. They can perform 100 joules of work. However, the system on the left can do it at a much faster rate. It could transfer, or it could perform the same amount of work of 100 joules in simply 1 second. The other system is slower. It performs the same work but over a longer period of time. So because it's slower, it has less power. The power is 10 watts. The other one, it's 100 watts. This system can transfer energy at a much faster rate. It can get the job done in 1 second as opposed to 10 seconds. So as you can see, power represents the energy transferred, the rate of energy transferred, like how fast energy is being transferred. So power is the rate of change of energy per unit time. Now, going back to the last example that we had, where the battery delivered a power of 90 watts. So if the circuit is allowed to run for 10 minutes, how much energy is transferred by the battery in a time of 10 minutes? So we know that work is equal to power multiplied by time, if power is work over time. If you multiply both sides by t, you get this equation. But let's solve it as a unit conversion. Let's start with time. Time is 10 minutes. Now, 90 watts represents 90 joules per second, so we need to convert minutes to seconds. In 1 minute, there are 60 seconds. Now you want to set it up in such a way that the unit minutes cancel. And 90 watts represents 90 joules of energy being transferred every second. So 60 times 90. What is the value of 60 times 90? We know 6 times 9 is 54, and if you add the 2 zeros, it's 5400. And then times 10, that's 54,000. So 54,000 joules of energy will be transferred in 10 minutes if the battery is delivering 90 watts of power. Now let's solve another series circuit problem. This time we're going to have 3 resistors instead of 2. So let's say the resistance of the first circuit is, the first resistor is 5 ohms, the second one is 3, and the last resistor has a value of 2 ohms. And let's say the voltage across the battery is 60 volts. Calculate the current that flows through the circuit. So first you got to find the total resistance, which is R1 plus R2 plus R3. So that's 5 plus 3 plus 2, which is 10 ohms. Next, we need to use V equals IR to calculate the current in the circuit. So the voltage is 60, the resistance is 10, so therefore 60 divided by 10 will give us the current of 6 amps. So 6 amps of current flows through the circuit in this particular example. Now what is the voltage drop across each resistor? So we need to use V equals IR. It's going to be the current that flows through the resistor multiplied by the value of the resistance. So across the 5 ohm resistor, it's 6 times 5, which is 30 volts. And across the 3 ohm resistor, it's 6 times 3, which is 18 volts. And across the 2 ohm resistor, it's 6 times 2, which is 12 volts. Notice that 30 plus 18 plus 12 adds up to 60. The sum of the voltage drops of the resistor must add to the voltage of the battery, which is in harmony with Kirchhoff's voltage law. Now let's calculate the power delivered by the battery and absorbed by the resistors. So for the battery, let's use V times I. So we have a voltage of 60 volts across the battery, and it delivers 6 amps of current. 6 times 6 is 36, so 6 times 60 is 360. So the battery delivers 360 watts of power. Now the first resistor, it absorbs how much power? Let's see. Let's use the equation I squared R. So the current that flows through it is 6 amps times the resistance of 5. So 5 times 6 is 30, and 30 times another 6 is 180. So this resistor absorbs 180 watts of power. Now what about the 3 ohm resistor? How much power does it absorb? Let's use P equals VI. The voltage across the 3 ohm resistor is 18, and the current that flows through it is 6. So what is 18 times 6? 10 times 6 is 60, 8 times 6 is 48. 60 plus 48 is 108. Now what about the last one? Let's use the third form of the equation. So the voltage across the resistor is 12, and the resistance itself is 2. 12 divided by 2 is 6. 6 times the other 12 is 72. So if we add these two values, that's 180 watts plus another 180 adds up to 360. So the power delivered by the battery equals the sum of the powers absorbed by the resistors. So energy is conserved in that particular example. Now let's move on to a parallel circuit. A circuit with 2 resistors. Remember, a parallel circuit is a circuit where the current has multiple paths to flow. Now the voltage of the battery is going to be 24 volts, and we're going to use a 6 ohm resistor and an 8 ohm resistor. Now how can we calculate the current that flows through each resistor? Now what you need to know is that the voltage across 2 resistors connected in parallel is the same. In this case, 24 volts. Both resistors are connected across the same battery. So if the potential at the bottom is 0, at the top is 24. So let's use the equation V equals IR. So let's start with the 6 ohm resistor. There's 24 volts across the 6 ohm resistor. So 24 divided by 6 will give us a current of 4 amps. Current flows in a direction from high voltage to low voltage, much in the same way as water flows from a high position to a low position. Water is not going to flow from a low position to a high position. Gravity is going to pull it down. So current, in a similar sense, flows from a high potential to a low potential. Voltage can also be called potential difference or electric potential. Some textbooks describe it as electromotive force or electron moving force. Now what about the 8 ohm resistor? What is the current that flows through it? So using the same equation, V equals IR, Ohm's law, the voltage is 24 volts and the resistance is 8. So all you got to do is divide 24 by 8 and you can get the current that flows through it. So 24 divided by 8 is 3. So 3 amps of current flows through the 8 ohm resistor. Now what is the current that leaves the battery? How much is it? The current that leaves the battery is equal to the sum of the currents that flow through the two resistors. It's 4 plus 3, which is 7 amps. So 7 amps flows in this direction. Now, if we focus on this point right here, 7 amps of current approaches that point, 4 amps goes down, and 3 amps travel this way. This is related to Kirchhoff's current law. The current that enters the point must equal the total current that leaves the point, which is true. 7 amps of current approaches the point, and 7 amps of current moves away from the point. The 4 amp current and the 3 amp current, which adds up to 7, they both move away from that point. So that's in harmony with Kirchhoff's current law. Now the last thing that we need to do in this circuit is calculate, actually there's two things we need to do. We need to find the equivalent resistance and the power delivered by the battery and absorbed by the two resistors. Now to find the total resistance of the circuit, there's two methods that we can use. First, let's use Ohm's law. V is equal to IR. The total voltage of the battery is 24 volts, and the current that leaves the battery is 7 amps. So then this network of resistors can be viewed as one equivalent resistance if you use the total voltage and the current that leaves the battery. So that equivalent resistance is basically 24 divided by 7, which as a decimal is about 3.43. So the equivalent resistance is about 3.43 ohms. Notice that the equivalent resistance, or the total resistance of the circuit, is less than 6 or 8. In a series circuit, as you add resistors, the total resistance increases. But in a parallel circuit, as you add resistors, the total resistance decreases, because as you add a new branch, more current can flow through the circuit. If the current goes up, the resistance goes down. And if the resistance goes up, current goes down. So these two are inversely related if the voltage is held constant. Now there's another way in which you can calculate the equivalent resistance. You can use this equation. 1 over R, let's say R total, which is the same as Req, is equal to 1 over R1 plus 1 over R2. So if you raise both sides to the minus 1, then you get this equation. RT is equal to parentheses 1 over 6 plus 1 over 8 raised to the minus 1. So if you type that in the calculator, you're going to get the same answer, 24 over 7, which is 3.43 ohms. So you can find the total resistance both ways. And now let's calculate the power delivered by the battery. So P is equal to VI. The voltage is 24 and the current is 7. So 24 times 7, that's 168 watts delivered by the battery. Now what is the power absorbed by the 6 ohm resistor? So let's use this form of the equation, I squared R. So we have a current of 4 amps that flow through it, and a resistance is 6. 4 times 4 is 16. 16 times 6 is 96. So 96 watts is absorbed by the 6 ohm resistor. For the last one, let's use VI. If we use V squared over R, we will have to square 24. Actually, we could do it a different way. Let's use V squared over R. So what is 24 squared divided by 8? In this case, let's divide first. 24 divided by 8 is 3. So 3 times the other 24 is 72. Notice that 96 is equal to, 168 is equal to 96 plus 72. The total power delivered by the battery equals the total power absorbed by the two resistors. Now let's try one more example with a parallel circuit. So let's say the voltage is 100 volts. Maybe that's too much. Let's say 20. And let's choose a 2 ohm resistor, a 4 ohm resistor, and a 5 ohm resistor. So to find the current that flows through each resistor, we need to use Ohm's law of V equals IR. The current is going to be the voltage divided by the resistance. So remember, the voltage across each resistor connected in parallel is the same. It's 20 volts. So 20 divided by 2 is 10. So 10 amps of current flows through the 2 ohm resistor. 20 divided by 4 is 5. So 5 amps of current flows through the 4 ohm resistor. And 20 divided by 5 is 4. So 4 amps of current flow through the 5 ohm resistor, which means that a total of 10 plus 5 plus 4, or 19 amps, leaves the battery. Now, here's a question for you. Once the 19 amp of current reaches this point, how much current flows in this direction? So 10 amps goes in a downward direction. 19 minus 10 is 9. So 9 amps of current flows this way. Now, once the 9 amps of current reaches this point, 5 is going to go down. So 4 travels this way because 9 minus 5 is 4. So we have 4 amps of current flowing in this branch. Then it's going to meet up with the 5 amp current. 4 plus 5 is 9, so 9 is going to go this way. And then that's going to meet up with the 10 amp current to add up to 19. And 19 amps of current flows through the battery. So you can see how it works, according to Kirchhoff's current law. Now that we have all the currents in the circuit, what about the power delivered by the battery and the power absorbed by each resistor? Go ahead and find the answer for that. So P is equal to VI. For the battery, it has a voltage of 20 volts and it delivers 19 amps of current. So the power delivered by the battery is 380 watts. Now what about the power absorbed by the 2 ohm resistor? So what we could do is simply use the same equation, P equals VI. So the voltage is 20 volts across it times the current of 10 amps that flow through it. So 20 times 10, that's 200. So the 2 ohm resistor absorbs 200 watts of power. Now for the 4 ohm resistor, it's going to be the voltage of 20 volts times 5 amps. So 20 times 5, that's 100 watts of power. And for the last resistor, it's 20 volts times 4 amps, which is 80 watts of power. So if you add 200 watts plus 100, that's 300, plus 80, that's 380, which equals the total power delivered by the battery. Now what about the equivalent resistance? Let's find it using both techniques as we did in the last example. So using Ohm's law, the voltage of the battery is 20, the total current is 19, so the total resistance is 20 divided by 19, which is 1.05. And it makes sense. The total resistance is going to be less than any of the 3 resistors. So it has to be less than a 2 ohm resistor if we have a parallel circuit. Now we can also calculate it using this equation. 1 over R1 plus 1 over R2 plus 1 over R3 enclosed in parentheses and raised to the negative 1 power. So it's 1 over 2 plus 1 over 4 plus 1 over 5 raised to the minus 1. If you type it in, you should get 1.05 as your answer. So now you know how to solve a series and a parallel circuit. Just to review, In a series circuit, there's only one path for the current to flow. And in a parallel circuit, it contains multiple paths for the current to flow. In a series circuit, whenever you have resistors connected in series, the current that flows through those resistors is the same current. Whenever you have resistors connected in parallel, the voltage across those resistors is the same voltage. So that is it for this video. Thanks for watching and have a great day.